EDX Core Pure, vectors 1, the scalar product. The angle between two vectors. Finding the angle between 2D vectors. Rearranging the scalar product formula to find angles gives us cos theta equals a dot b over modulus of a modulus of b. So for example, to find the angle between these two vectors, where b 7,3 in A is 5,0, it will find the angle. Notice b and a are pointing away from this corner, so it will find the angle between them. They both have the same sense away from the common point. So to find the angle between them, first thing I want to do is find a dotted with b. So a dotted with b is 5,0 dotted with 7,3, which is 35, add nothing is 35. We need to know the magnitude of a. So doing Pythagoras on the 5,0 gives us a fairly obvious answer of 5. And the magnitude of b is Pythagoras on the 7 and the 3 gives us the square root of 58. So using this rearranged dot product, we can say that cos theta is a dotted with b, which is 35, over the modulus of a, which is 5, times modulus of b, root 58, which gives us theta equals 23.2 degrees to 3 significant figures. We can use the same rearranged formula for cos theta to find the angle between three-dimensional vectors. So again, I'm going to look for p dotted with q. So p dotted with q is minus 4 plus 3 threes are 9. So that gives us 1. We need to find the magnitude of p. So that's Pythagoras on the 2, the minus 4 and the 3. So that'll be the square root of 4 add 16 add 9, the square root of 29. And we need to find the magnitude of q, which is Pythagoras on the minus 2, 1, 3. So that would give me the square root of minus 2 squared plus 1 squared plus 3 squared, which is root 14. So now we can apply cos theta equals p dotted with q, which is 1, over the magnitude of p times the magnitude of q, which gives me theta equals 87.2 degrees. Again, that's to 3 significant figures. So what happens if a dot b is 0? So if a dot b is 0, then we get cos theta equals 0 over the magnitude of a times the magnitude of b. Now we know that the magnitude of a and the magnitude of b can't be 0, because that would mean the vectors were null vectors, and we are looking for the angle between two vectors. So it must be that cos theta is 0. That means that theta is 90 degrees and a is perpendicular to b, and that's a commonly used symbol for perpendicular. A is perpendicular to b. And if I just make up a quick example, if we look at the vector little a is, say, 4, 2, and the vector little b is minus 2, 4, we can see the gradient of this line is a half, and the gradient of that line is minus 2, so these are indeed perpendicular vectors. And if we dot them together, a dotted with b, we get 4, 2 dotted with minus 2, 4, which in this case would be minus 8 plus 8, which is 0. So we've got a little example there showing us that it does give us perpendicular vectors. So here A is 2 minus 1 minus 3. Which vector is not perpendicular to A? So I'm going to work through them in order and see which one is the odd one out. So if we try the first one, 1 minus 1, 1, dotting it with A, gives me 2 plus 1 minus 3 is 0. As soon as I get the answer 0, I know that it is perpendicular to A. So that's a perpendicular vector. So the first one's definitely perpendicular. If we move on to the second one, 3, 0, 2, dotted with 2 minus 1 minus 3, gives me 6, add nothing, take away 6, which is 0. And again, that vector must be perpendicular to A. So the first two are perpendicular to A, and now testing the... So if we look at this third vector now, 5 minus 1, 3, dot it with A, we get 10 plus 1, take away 9 is 2, which is definitely not 0, so this third one is not perpendicular to A. So we have perpendicular, perpendicular, not perpendicular. If we just test the fourth one, 2, 1, 1, dotting it with A, gives me 4 minus 1 minus 3, which is 0, and therefore the fourth one is perpendicular. It's worth noting, although the first, second and fourth vectors are perpendicular to A, because we're in 3 dimensions, that does not mean they are parallel to each other. So here we've got to find the value of little k so that A and B are parallel vectors. So if A and B are parallel vectors, we should be able to take vector A and multiply it by a value, a number, in order to get to vector B. One of them is a scalar multiple of the other. So if you look at the top elements first, I think we can multiply minus 2 by minus a half to create this top element of 1. And now if you apply it to the bottom element, you get minus a half times 3 needs to be k, so k is minus 3 over 2. So on part 2, it's a different problem now. We want A and B to be perpendicular. So if they're perpendicular, we need A dotted with B to be 0. So if we dot them together, we get minus 2 plus 3k is 0, and that gives me k is 2 thirds. So here we've got 3 points, A, B, C, with the coordinates given in 3 dimensions. We want to show that the angle ABC is a right angle. So if I just do a quick sketch of the situation. So we've got A given, B given, and C given. We're trying to show that this angle here is 90 degrees. So I'm going to do that by finding the vector from B to A, finding the vector from B to C, and dotting them together to see what we get. So the vector from B to A is OA take away OB. So that is minus 1, 2, minus 1. The vector from B towards C is OC take away OB, which is 7, 4, 1. And I'm now going to take the vector from B to A and dot it with a vector from B to C to see what we get. So that's minus 1, 2, minus 1, dotted with 7, 4, 1 is minus 7 plus 8 minus 1, which is 0, which tells me 2 things. It tells me that BA, the vector from B to A, is perpendicular to the vector from B to C, and if they're perpendicular vectors, the angle ABC must be 90 degrees. as required. So that brings us to the end of vector 1, the scalar product.